All right, so right at the top of this paper, it just talks about what an exact solution is. So in your review that I handed you, you're going to have some questions that ask you to find an exact solution. So just to remind you how to find an exact solution. So we're going to do 24 divided by 14 equals x. I'm going to do x squared equals 5. I'm going to do both of those. How can we do this? Divide them? Do I need to pull out my calculator? Do I need to? I can't tell by your faces. You don't know the answer. Jacob, do you need your calculator for that? Sure? It makes it easier. Of course it does, because you're not doing any work yourself. How else? Like a fraction. So that's what I would do. I do 24 over 14, and then I go, that reduced. What number am I going to factor out of 24 and 14? 2. So I've got 12 over 7. So let me ask again, am I going to type that in my calculator? What's your calculator going to tell you? It's going to tell me the decimal. What's exact solution mean? What, Cindy? Exact solution means you cannot round it. So if I were going to write this, that would be a rounded number. So the fraction is the exact solution, because I did not round that. So this next one here, exact solution, how would I get x by itself? I'm going to square root. And what would I get for x? Kia. Remembering that very important rule, there are 2 answers. 5. Type square root 5 in my calculator. Is that an exact? All the numbers down? No, because any square root of a non-perfect square is a decimal that goes on forever and ever. It does not repeat. There's no patterns. So any square root that is not a perfect square would have to be rounded. So we do not write the rounded number. We just write this. This is the exact solution. So there's a couple of questions in your right that say exact solution. And then there are some that say use your graphing calculator. So here's a few examples. It says find the approximate solution. Hundredth. How many decimal places? It's 100. Did you hear me try to say 2? I wanted to say it really bad. 2 decimal places. Let's go to y equals. Let's type y1 and y2 in. I'm going to zoom in just a little bit. For those of you that did not download this, oops. For those of you that did not download this, it's totally fine that you didn't download it. You could just copy it from the board. Type that into the calculator. And we're all doing this because we got to make sure we are typing it in correctly. Just watching it is not good enough. I'm just letting everybody see it before I put my screen up there. If you hit graph, if you hit graph and you have an error, you need to tell me immediately. Please do not wait till I'm done with notes to say, I never got question A. Like, just tell me immediately, interrupt, it's okay. I want to make sure that everybody's calculator is doing it what it should be. I know I had a few errors yesterday. looks like. Now, maybe your window's totally different than my window. Do you remember how to fix your window? Does anybody remember how to fix the window? What is it? Fix the window. So nobody knows it? Everybody together. Hit zoom. And then hit 6. Zoom 6 fixes your window. It makes it that nice 10 to 10, negative 10 to 10. Yes?
I graphed one, but it just doesn't look like that.
So if you graphed yours and it just doesn't look like that, probably typed something in wrong. I'll come back. So it's minus 3. Is that the only thing that was different? Was it the line, or did you not make that close? Yeah. I don't think you copied the question. Let's go back there. There's like 4 terms. It looked like you only had 3 terms. Am I correct? And you're right there too. Did everybody else copy it wrong? Everybody get it? No? You have your calculator? I just didn't see. Somebody not have a calculator to use today? I forgot which class this was. So what are you doing if you don't have a calculator? What? Good, but what are you going to do on a test? When are you going to practice on your graphing calculator so you know how to do it on the test? That's what I'm worried about. I did have somebody leave one. If you have one, as long as you hand it back to me. I don't know whose it is. They don't put their name in it. If anybody wants to borrow one. Anybody want to borrow? 6 of you that don't have one today. So now what we're going to do is we are going to find where the graphs cross. How many intersections? How many solutions? There's 3 solutions. Okay, to do this, we're going to use our magical calc button. This is the best button. Answers are given to you. You're going to do second trace, and you look at your choices, and looks like I'm going to pick intersect because I want to find where they intersect. So 5. Now, it asks you first curve. It does not know. This is not a living and thinking person. It does not know what you want. It does not know what you graphed. So it says first curve even though it's a line. Don't get mad at it. When you typed them into y equals, the first one that you typed in will come up first when it asks for first curve. Up here, you know which one the little flashing bug is sitting on, no matter what calculator you have. Do you see the equation? Okay, and then if you have the color, it's even that color. It also tells you down here where it is. So if the little bug is not on the screen, and you're like, I don't know which equation it's sitting on, it tells you where it is, and you can use left or right arrows to move it. It just has to know that it's sitting on your first equation. So enter. Now it says second curve, and I say, I don't know where my bug went. But I look down here, first of all, I can tell it's on the second one because I have a color one, it's in red. Also, it tells me it's on. But down here it's telling me it's at y is negative 16, and I know my y goes all the way down to just negative 10. So I'm just going to use my left arrow until I see it. You don't even have to move it, but some people will just want to make sure that it's on the correct one. Yes?
How did you get to the second?
I hit enter, and then it automatically says second curve. You there now? Okay. So now, a second curve, I'm sitting on the second curve. I'm going to tell the calculator, yep, that's my second one. So what you're telling your calculator is we're going to look for an intersection between which 2 equations. Okay? We're going to look for an intersection between these 2. Now, it asks for guess because there are how many different ones? 3. The calculator will not give you 3 at a time. So you're going to talk about which one you're looking at. I like to type. I don't like to use my arrows to do this. You can use your arrows to do this. I like to type. If I type, it's asking for the X. It's asking for the X that is closest to the intersection. I'm going to go with the left one first. So I'm going to look straight down below this intersection, and it looks like -1, -2, -3, around -4, maybe around -3. That's kind of where it looks like. So if I start typing -4, this little X box opens up, and when I'm happy with what I typed in, I hit enter. When I do that, it tells me the intersection. Yay. I'm going to write down that answer, and I'm going to round it correctly to 2 decimal places. Let's go over rounding. Isn't that fun? We have to go over rounding. That's so fun, isn't it? Yeah. All right, so I've got -3.518. So when I'm doing rounding, we're looking at the 3rd decimal place, which is an 8. Looking at the 3rd decimal place. That tells me to do what? Decimal place goes up. So I got -3.52. And then same thing with the Y. I've got 4.036. That's my 3rd decimal places. So I get 4.04. All right, so we got one of the intersections. To get another one, you just have to do the whole process again. So second trace, intersect. First curve, make sure it's sitting on the first line. Second curve, make sure it's sitting on the second one. You hit enter. So when I go to guess, I'm going to guess something that looks like it is close to the second intersection. I'm going to guess the X value. What X value would you guys type in? What do you think? Kenny, what do you think? So -3 would be all the way over here. But I'm trying to get this one. Yeah, I'm thinking -2. Because if I type in -3, it might just give me this answer again. Maybe it won't. I'm going to type in -2. And it's -2.178194. So I'm going to look at -2.178. What does the 8 tell me to do? Round up. -2.18. My Y value is 1.356. So what am I going to write down? Paige, what am I going to write down?
1.36.
Yeah, 1.36. Okay, and then we've got the third one. Second trace, intersect, first curve. I'm going to type in a 2. It's actually at 1. Let's go rounding for this one. This is one that people struggle with for rounding. Since I'm rounding traces, I'm going to look at the 3rd decimal place, which is a 6. What does the 6 tell me to do? Round it up. But I'm going to round up a 9. What's above a 9? A 10. So I'll make it a 0, but what will I do with the 10th place? Move the 6 to a 7. So I'm going to have 1.70. If you're asked to round to 2 decimal places, put 2 decimal places in. And then the other part, -6.392. The 2 says keep it the same. So -6.39. Did anybody find this really easy? Only like 3 of us found that easy? Oh wait, some of you don't have a calculator. Okay. All right, I hope that was easy, but we're going to do a harder one. The last one we're going to do together is same stuff, same exact question. X squared plus y squared equals 12, and x equals y plus 1 squared. So what's my first step? Gage,
Would you move the x squared over?
why are you saying to do that?
Because the calculator says y equals, and then you use square roots on sides.
All right, so my calculator, this is the advantage of Desmos. You don't have to move stuff around. Unfortunately, with the calculator, you do. So because the calculator says y equals, if we're going to use y equals. So you said